In this example, we're going to have kind of a business feel to it. We're going to be talking about average and marginal cost. So just an average is always just referring to a slope. So that just means you need 2 points and find the slope between those 2 points. We're going to be given an equation that has a c of x, which is going to be a cost function. There it is. And then if you take the derivative of it, that's going to be what we call the marginal cost function, which is the rate at which the cost is changing to produce one more item, right? Or efficiency is starting to happen. Is it getting cheaper to produce more? Sometimes yes, sometimes no, right? There it depends. And maybe there's a point that it isn't. So our situation is, suppose the cost of producing X items is given by this function for items between 0 and 1,000. Okay. And then it says we're going to be determining what's the average and marginal cost functions. So the average is average cost. For this example is going to be a little bit different because they're not giving us like coordinates or anything. And so how we would find it is actually taking our cost function and dividing it by x. Okay, so our cost function is this, negative 0.02 x squared plus 50x plus 100. And we're going to be dividing it by x. This is like a sum divided by the number. So if we look at the math on this, we could actually divide this x into each one, because let's see, that's going to turn into a negative 0.02 x plus, divide the x into that, so that's going to be a plus 50. And then divide the x into this, and that's going to be 100 over x. All right, so that's your average cost equation. Right? And then the other part is, what is our marginal? Marginal goes back to our marginal cost function is going to be the derivative. So if we do the derivative of that, that's going to give us c prime of x is going to equal, that's going to multiply in front, so 0.04x plus 50. The derivative of a constant is 0. So there's our marginal. And let's answer some questions. So first question is, determine the average and marginal cost for the first 100 items and interpret these answers, these values. So our average cost for the first 100 is going to be negative 0.02 times, because we're using this, 100 plus 50 plus 100 over 100. So if we do that math, we multiply this, that's going to get us a negative 2 plus 50 plus 1, which adds up to 49. So that idea is it's $49 per item at an average cost. Okay. Then what's the marginal cost at 100? Right, when we're at 100 items, are we increasing or decreasing our cost per item? So if you do this derivative, 0.04 times 100 plus 50. And then we're going to get, that's going to be negative 4 plus 50, which is 46. So we're increasing per item at that time. But if you notice, the more you start to do, the bigger this negative is. And so the more impact we're going to have reducing it down. Right? So if we do the next one, you can kind of get a feel for it. So this is for the first 100 items. Now let's do it for the first 900 items. So our average cost is going to be the same equation right here at negative 0.02 times 900 plus 50 plus 100 over 900. All right, and if we throw that all into the calculator, we're going to get about $32 per item. So that's good, more efficient. And then what's the rate? So like right now, this was a positive rate, but then what's happened over time or over our increase in production is negative 0.04 times 900 plus 50. And so we have a negative 36 plus 50 is a $14 per item, and that's a rate. And those are our answers for that. So that was working with a little bit more of a business kind of an idea with these things with an average cost and a marginal cost.